Hello Year 12, today what we're looking at is the empirical rule. So for the probability of minus 1 is less than or equal to z is less than or equal to 1, the probability of minus 2 is less than or equal to z is less than or equal to 2, and the probability of minus 3 is less than or equal to z is less than or equal to 3, is the probability that values in a normal distribution will fall within 1, 2, or 3 standard deviations of the mean respectively. These probabilities are a part of the empirical rule. So for the empirical rule, we have three different ones. And so we have that approximately 68% of students that lie within one standard deviation of the mean with Z scores between -1 and 1. We have approximately 95% of students lie within 2 standard deviations of the mean, so that's that they have Z scores between -2 and 2, and approximately 99.7% of the scores lie within 3 standard deviations of the mean with Z scores between -3 and 3. So we can see our normal distribution curves here, and it highlights what the percentages are. We can cut these in half, obviously, and so the whole thing's 68%, so this little bit here is going to be 34%, if that makes sense. So on your reference sheet, this is on your reference sheet for you, so you do not need to remember this, you just need to know where it is, and it's on page 2, and this is a snippet straight from your reference sheet to help you out. So for our examples, we have a data set is normally distributed with a mean of 20 and a standard deviation of 3. What percentage of scores lie between 17 and 23? So for this, the first step that you should do is on your normal distribution curve, right below where your mean is. So your mean, we have been given a mean of 20, and then we have our standard deviation of is 3. So we're going to go up by 3 for each of our standard deviations, and then down by 3, 14, 11, and then we can see where they lie between. So our first one is between 17 and 23. So 17 and 23 is here. So it's 1 standard deviation either side of the mean. So 1 standard deviation either side of the mean. If we go back to our reference sheet, or that's here, it says approximately 68% of the scores have Z scores between -1 and 1. So our answer here is 68%. Now we want to look between 14 and 26. So for 14 and 26, so 14 is here. So this gets added on, and 26 is here. So between 14 and 26, that's 2 standard deviations either side of the mean, and it includes everything that we have coloured in. So if we just go back to our reference sheet, between -2 and 2 is 95%. So this will be 95% here. Now we have 11 and 29. So if we shade in 11 to 29, we have that it's the whole, that's between 3 standard deviations either side of the mean. So if we go back to our reference sheet, 3 standard deviations either side of the mean is 99.7. So our answer here is 99.7%. Now for example 2, we have a normal distribution has a mean of 65.2 and a standard deviation of 1.3. What percentage of scores lie between the following? So our mean is at 0, so 65.2, and then we need to calculate the standard deviation. So the standard deviation is 1.3, so 1 standard deviation above the mean is 66.5. 2 standard deviations above the mean is 67.8, and 3 standard deviations above the mean is 69.1. So then 1 standard deviation below the mean is 63.9. Another standard deviation below the mean is 62.6, and 3 standard deviations below the mean is 61.3. Now what we want to do is we want to find what percentage of scores lie between 61.3, so 61.3 is here, and 65.2. So that is this part here. So we're going 3 standard deviations below the mean only. So this whole thing of 3 standard deviations, so from here to here, is 99.7% if we were to look back at our reference sheet. So that means from our -3 to 0, that is going to be half of 99.7, because it's even spacing. So this will be 49.85% of scores lie between our mean and 3 standard deviations below the mean. So that means this will equal 49.85%. Now what we have is we have 65.2 and 66.5. So 65.2 and 66.5. So that's this little bit here. Now before we talked about how between -1 and 1 was a total of 68. Yes, 68%. So that means that, we'll go purple, so between 0 and 1 is half of 68. So half of 68 is 34%. So that means just one standard deviation above the mean is 34% of the scores. And finally, we have 62.6, which is here, and 69.1, which is here. So we're talking about all of these scores and all of these scores. So what we need to do is we need to account for all these scores. So like I said before, we have that between -3 to 3 is 99.7, and so 1/2 of it is 49.85, as we discovered in part A. So that means that this other half is 49.85%. So we can add that on. So that means that it's going to equal 49.85%. And then all we need to do is we need to find out, so we've currently done this part is done. We just now need to work out what this part here is. So from -2 to 2 is 95% of the scores. So that is 95% of the scores. So now we just want this bottom half here. So half of 95 is 47.5%. So we need to add that on, plus 47.5%. So add the two together, 49.85 plus 47.5 gives us that there is 97.35% of the scores here. So it's really important that you understand that each strip is even and you know how to split them all up.